Good morning, students. I hope all you are safe. See, in this maths class, we are going to learn about the locus of complex numbers, geometry and locus of complex numbers. That's equation of complex form of a circle. Also, we are going to learn in this section. Okay. See, locus. What is the locus of Z or locus of complex numbers? That is finding the given complex number or converting the Z in the format of equation in term of X and Y. Okay. Now here example 2.18, given the complex number Z is equal to 3 plus 2i, represent the complex numbers Z, Iz and Z plus Iz in one organt diagram. Organt diagram, what is that? That drawing the graph, keeping the x-axis as real part and y-axis as imaginary part. So we have to find out what is Iz and Z plus Iz. And we have to mark all these 3 points in the organt diagram. After drawing that, show that these complex numbers form the vertices of isosceles right triangle. So isosceles, so far we should find out the distance of all the 3 sides. Now isosceles triangle means 2 sides are equal. Isosceles right triangle means we have to prove, what is that? One angle should be 90 degree. That we can prove with using Pythagoras theorem. Square of the hypotenuse is equal to sum of the square of other 2 sides. Isn't it? Okay, this is what we are going to do in this. So anyway, first to mark it in organt diagram, I am taking given Z is equal to 3 plus 2i. The next, this is 1 point. The next I into Z. So I into 3 plus 2i. So this is 3i plus 2i into I is I square. So we know that the value of I square is minus 1. So we may get 3i minus 2 or minus 2 plus 3i. Because always we will used to write real part then imaginary part. Okay. Then the third one is Z plus Iz. So 3 plus 2i plus Iz, we have found out that is minus 2 plus 3i. So we may get 3 minus 2, 1. 2i plus 3i is 5i. So we have found out all these 3. Now we have to draw everything in the organt diagram. See, this is real part. And this y-axis we have to keep it as imaginary part. Now shall we mark it? This is 3 plus 2i means 3 comma 2. Isn't it? Already we have drawn. See? Exact this real part 3 and imaginary part 2. Actually this is Z. Then Iz minus 2 and 3. Minus 2 and 3. This is Iz. Z plus Iz. This is 1 comma 5. So this is Z plus Iz. Okay, we have represented this in the organt diagram. So first part over. The next part is, see, this all we have drawn from the origin. So that only we have got this diagram. Okay. In order to prove that the vertices forms an isosceles right triangle, I am going to take the vertices as A, B, C. Let A, B and C be Z, Iz and See, when we take it in this form, this is second B will be Z plus IZ and C is IZ. Okay. So, this is A and this is B, C respectively. So, we have taken the points as A, B, C. Now, we should find out the distance between the two, all the vertices. So, AB means we know that B value Z plus IZ minus A, the value of A is Z. See, so only I into Z, IZ value we know that is minus 2 plus 3I. In order to find out that is square root of minus 2 the whole square plus 3 square. That is root 4 plus 9 which is equal to root 13. See, in order to prove that right angle, we need the square of the sides. So, I am just finding out the square also. AB square is equal to root 13 the whole square which is equal to 13. Same way we can find out BC. BC is modulus C. C is IZ minus B. That is Z plus IZ. Or modulus IZ minus Z minus IZ. So, modulus of minus Z. The value of Z is 3 plus 2I. Anyway, minus that is root of minus 3 the whole square plus minus 2 the whole square. See, even since it's inside the modulus, we can leave the minus, okay? Since you should not get confusion, that's why I have taken that value also. That is root 3 square 9 plus minus 2 the whole square is 4 which is equal to root 13. So, BC square root 13 the whole square which is equal to 13. Almost we have got it, two sides are equal, isn't it? AB also root 13, BC is also equal to root 13. But in the question they asked isosceles right triangle. So, we have to find out the other side CA also. CA is equal to the value of A Z minus Z plus IZ. It's modulus Z see, CA modulus Z minus Z plus IZ, simplify Z minus Z minus IZ. Both Z and minus Z will get cancelled. We have got it minus I into Z. Actually, see the value of A, the vertices A is Z, vertices A is Z and vertices C is IZ. So, when we find out CA, that is modulus Z minus IZ. Okay, not Z minus Z plus IZ, that is Z minus IZ. The value of Z is 3 plus 2I minus IZ, that is minus 2 plus 3I. So, you may get 3 plus 2I minus of minus 2 plus 2 and minus 3I. So, that is 3 plus 2, 5, 2I minus 3I is minus I. Now, we can find out the modulus value. That is root of 5 square plus minus 1 the whole square. 5 square is 25 plus minus 1 the whole square is 1 which is equal to root 26. So, when we find out CA the whole square, we make it root 26 the whole square. Now, root and square will be removed. So, we will be getting only 26. Now, the other two values are 13, isn't it? So, see, AB the whole square plus BZ the whole square is equal to 13 plus 13 which is equal to 26. 26 that is CA the whole square. So here B is common, isn't it? So it is understood angle B is equal to 90 degree, and that we got AB equal to BC is equal to root 30. So two sides are equal and one angle is equal to 90 degree. Therefore, triangle ABC is an isosceles triangle. In the previous exercise example, we did equilateral triangle. Here we have did isosceles right triangle, not isosceles triangle. Actually, this is isosceles right triangle. Okay. Now we are going to move to the next part. In this, there is no exercise problem also given. Okay. Now the next part we are going to learn is equation of complex form of a circle. Listen, the definition of a circle is defined as the locus of a point which moves in a plane such that its distance from the fixed point in that plane is always constant. See, a fixed point is there with a common distance. When we move, we have got a circle. So, which moves in a plane such that its distance from this fixed plane is always constant. So, the fixed point is called the center and this constant distance is called the radius. So, I am taking it as R, let it be Z0. So, the locus of the equation which satisfies modulus Z minus Z0 equal to R is the equation of the circle in complex form. So, Z0 is the center and R is the radius. Okay. The locus of Z that satisfies the equation modulus Z minus Z0 equal to R, where Z0 is the fixed point, that is the center, and R is the radius. Okay, when a complex form number is given and they can ask, show that the given points is the equation of a circle. So, if we could bring it in this form, Z minus Z0 equal to R, we will say that forms a circle. And Z0 is the center and R is the radius. Is that clear? Suppose if they have given, that is modulus Z minus Z0 less than R, then it represents the points or in interior of the circle. If it is greater than the radius R, then the point is the exterior of the circle. Okay, point is in the exterior of the circle or it is in the interior of the circle. So, normally we used to take Z is equal to X plus Iy. Suppose when we find out modulus Z, what happen? Root of X square plus Y square. If we take that, modulus Z is equal to R. Modulus Z, root of X square plus Y square is equal to R. Square it, when we square on both sides, we may get X square plus Y square is equal to R square. This we know, that's the equation of a circle with center at the origin and radius with radius R. So, only modulus Z means, what is the meaning? Minus Z0 will be there. That value is not there. That means the center is the origin. Okay, shall we do a problem? Then it will be, you can understand more. Example 2.19. Show that modulus 3Z minus 5 plus I equal to 4 represent a circle and find its center and radius. So, let me take it given. Modulus 3Z minus 5 plus I is equal to 4. Actually, when we take here Z should be alone. No coefficient should be there. So, I am taking it out. Okay, which implies when we take the 3 outside, we may get Z minus 5 by 3 plus I by 3 equal to 4. I have taken 3 outside. Now take this 3 to the next side, then it will become 4 divided by 3. This is z minus, I am taking the minus outside, so this is 5 by 3 plus will become minus I into 1 by 3. Now I am writing this is of the form modulus z minus z0 is equal to r. Is that clear? So now we can write therefore it represents a circle. Therefore it represents a circle. Then the question was asked, find its center and radius. Shall we write the center? Center is z0, but we used to write x comma y, isn't it? So center is equal to 5 by 3 comma minus 1 by 3. Then radius is equal to 4 divided by 3. Is that clear? Simple problem only. Okay. The next example 2.20, show that modulus z plus 2 minus I less than 2 represents interior point of a circle. Find its center and radius. So first we can check whether it is a circle or not. Okay. And we should find out what is the radius. If the radius is 2, then we can say this is all the points are interior points of a circle. If it is more than less than that 2, then we cannot say that answer. Okay, so first we will find it out whether it is a circle and what is the radius. See, for that I am going to consider that's modulus z plus 2 minus I equal to 2. So this is z, coefficient of z is 1. Actually for circle z minus z0. So I am taking minus outside. So this plus 2 will become minus 2, minus I will become plus I is equal to 2. See, this is minus into minus plus 2 and this is minus I. Value has not changed. So I can write this is of the form z minus modulus z minus z0 equal to r. Isn't it? Therefore it is a circle. It represents a circle with center minus 2, center at minus 2 plus I and radius 2. Isn't it? With the center at minus 2 plus I and radius 2. Here the question also asked with less than 2. Therefore, what we can say? Therefore, modulus z plus 2 minus I less than 2 represents all points inside the circle. That's all. So just they have asked us to show that the points. So first we have to find out the radius. If the radius and the given values are almost the same, we can say that represents the points are inside the circle. Okay. Now exercise 2.6, problem number 4. See, show that the following equations represent a circle and find its center and radius. Subdivision 1, that's modulus z minus 2 minus I equal to 3. I hope it will be easy, very easy. See, given modulus z minus 2 minus I equal to 3. First we will check whether the z has coefficient. No. Then we will try to write it in the form z minus z0. So take a minus outside. So we may get 2 plus I equal to 3. So now you can write this is of the form modulus z minus z0 equal to R. Therefore, it represents a circle. Isn't it? Now you can write center. Center is equal to 2, 1. And the radius is equal to 3. Is that clear? Now, the second subdivision is modulus 2z plus 2 minus 4i is equal to 2. So, we can take given modulus 2z plus 2 minus 4i is equal to 2. So, here when we check, here the coefficient is 2, isn't it? So, what we should do? Take the 2 outside. That's modulus z plus 2 divide 2 I have taken out. So, 1. 2 into 2 is 4. 2i is equal to 2. Shall we take this 2 to next side? This is 2 divided by 2. And here modulus z minus z0, isn't it? So, when we take minus, this plus 1 will become minus 1. This will become plus 2i. 2 and 2 will get cancelled. 1. Now, you can write this is of the form. This is of the form modulus z minus z0 equal to R. Therefore, it represents a circle. Is that clear? Therefore, it represents a circle. Now, we have to write the center. Center minus 1 comma plus 2, isn't it? Minus 1 comma 2 and radius is equal to 1. See, given that center equal to minus 2 comma 1 and radius is equal to 1. Now, subdivision 3, that's modulus 3z minus 6 plus 12i equal to 8. Actually, this is homework for you. This one subdivision alone, it's homework for you. I can give the answer. Center is equal to 2 comma minus 4. And the radius is equal to 8 by 3. Simple problem only, no? Only one homework I have given. Complete it. Okay? See now the next section. Let's obtain the Cartesian form of the locus of z. Cartesian form means we have to write it in x and y. Each of the following cases. Subdivision 1 is given modulus z equal to modulus z plus I. See, solution, I am taking, let z is equal to x plus iy. Okay. Now, given modulus z is equal to modulus z minus I. This is very simple. We have to substitute the value of z in the given condition. If you wanted to simplify, then find out the modulus value. After finding the modulus value, if there is square root, you have to square on both sides. Then simplify, you will get the answer. Okay? Simple question only. So, this is given condition. We can substitute the value of z. This is x plus iy equal to modulus x plus iy minus I. So, here only one real part and imaginary part is there. Here 2 part is there. So, we will bring it into symbol form. So, plus I when we take it out, y minus 1. Is that clear? Now, find out the modulus value here. When we find it out, that is root of x square plus y square. Right hand side, real part the whole square plus imaginary part, that is y minus 1 the whole square. Which implies when we square on both sides, square on both sides. What happens? X square plus y square equal to x square plus y minus 1 the whole square. Now we have to simplify and write the answer. See, x square plus y square equal to x square plus, this is of the form a minus b the whole square. So, a square y square minus 2ab, 2 into y into 1, 2y plus b square is 1 square. Now, bring all the terms to left hand side. X square plus y square minus x square minus y square minus 2y when it comes to left side plus 2y minus 1 equal to 0. See, x square minus x square, y square minus y square will get cancelled. So, 2y minus 1 equal to 0. Okay. This is the locus of Z in Cartesian form. Is that clear? We can do one more subdivision in this. See, subdivision 2, the given condition is modulus 2z minus 3 minus I is equal to 3. 2z minus 3 minus I is equal to 3. Here also we can take let z is equal to x plus iy. So, given modulus 2z minus 3 minus I equal to 3. Substitute the value 2 into x plus iy minus 3 minus I is equal to 3. So, first we have to bring this in separate real part plus I into imaginary part. Multiply it by 2x plus I into 2i minus 3 minus I is equal to 3. What are the real part here? That is 2x minus 3 plus I into imaginary part 2y minus 1 is equal to 3. Okay. Shall we find out that modulus value? Root of real part 2x minus 3 the whole square plus imaginary part 2y minus 1 the whole square is equal to 3. To remove the root, we will write square on both sides. So, when we square it, we make it 2x minus 3 the whole square plus 2y minus 1 the whole square is equal to 3 square. Now, we have to simplify and write the answer. See, a minus b the whole square, a square, 2x the whole square is 4x square minus 2ab, 2 into 2, 4, 4 into 3, 12x plus 3 square, that is 9. Okay, plus now this one. Here also this is of the form a minus b the whole square, 2y the whole square is 4y square minus 2ab, 2 into 2y, 4y plus b square, 1 square is 1 equal to 9. Now I am arranging in order 4x square plus 4y square, then x term minus 12x minus 4y, 9 plus 1 plus 10, bring that 9 here, minus 9 is equal to 0. So 4x square plus 4y square minus 12x minus 4y plus 10 minus 9, that is plus 1 equal to 0 is the locus of Z in Cartesian form. Is that clear? Simple only, no more. Substitute the value of Z, that is equal to x plus iy. Bring the real and imaginary part together. Then we have to simplify and write the answer. Is that clear? So only one problem, one subdivision is given for your homework. Complete it. In this, almost the examples over. We have to do the exercise problem. Okay. Be safe. Thank you. See you in the next class. Bye-bye.